For problem 27, we're first trying to eliminate the parameter to obtain an equation in x and y. So we're given this pair of parametric equations. So we have that x is going to be minus 7 cosine of 2t, and y is going to be minus 7 sine of 2t. So the way that we're going to eliminate the parameter t is we're going to use this identity here where the square of sine plus the square of cosine is equal to 1. So what we're going to do, we're going to, since we only have cosine and sine, we don't have the square, we're going to square the equations. So for the x one, squaring the left-hand side gives us x squared is equal to minus 7 squared, so 49 cosine squared of 2t. And now let's square the y equation. So y squared is going to be equal to minus 7 squared, so 49 sine squared 2t. So once we've gotten this, what we're going to do is we're going to add these two equations. So by adding the left-hand side, we get x squared plus y squared. And adding the right-hand side, we're going to do 49 cosine squared of 2t plus, let me move to the side, 49 sine squared of 2t. And now we're just going to factor out the 49. So 49 factor out, and that leaves us with cosine squared of 2t plus sine squared of 2t. And now we can see that, oops, forgot one parenthesis. Now we can see that this matches up exactly with our identity, right? That cosine squared of an angle plus the sine squared of that same angle is equal to 1. So this whole thing simplifies to just x squared plus y squared is equal to 49 times 1. So once we've gotten, this is our equation here. And what's left for us to do is to describe the curve and indicate the positive orientation. So let me erase all of this stuff here so that we have some room to work. So this equation here, x squared plus y squared is equal to 49. This is just a circle that is centered at the origin with radius 7. So maybe you can see that's 2, 4, 6, 8. And let me erase that as well. So 2, 4, 6, 8. And so this would just be a circle with radius 7 that would go something like this. So this would be the point 0, 0. So we can describe this curve as being a circle with radius 7 centered at the point 0, 0. So we have described the curve, and now we want to indicate the positive orientation and the path that it takes, because the parameter t is limited from 0 to pi. However, for each x and y, we can see that the argument is 2t. So where is the starting point? Well, it starts at the point where t is equal to 0. So let's plug that t is equal to 0 into the x and y equation just to see where the coordinates of where we're going to start. So we have that x is going to be equal to minus 7 times cosine of 2 times 0, so which is 0. And cosine of 0 is 1. So we're going to begin at the point x is minus 7. And y is going to be minus 7 times sine of 2 times 0, which is going to be sine of 0. And sine of 0 is just 0, so that's 0. So we're going to say that it begins at the point x is minus 7 and y 0 when t is equal to 0. That's the first boundary. Begins at the point minus 7, 0. So let's plot that in here. So minus 7, 0 would be over here. So that's where it starts. And now let's think about what is actually happening here. Well, t is positive, so we know that it's going to go in the positive orientation. If t were negative, it would go the other way around. So we know that we're going counterclockwise rather. But where is it going to end? The end value of the boundary of t is pi. So ordinarily, if we just had x is equal to minus 7 cosine of pi and y is equal to minus 7 sine of pi, what that means is that we would walk around a distance of pi around. So we go from here all the way out to there, and we would end like so. However, the argument here is 2 pi. So what that means is that it's going twice as fast. So whenever I plug in pi into the x and y equation, so let me rewrite this. So now let's plug in the upper boundary. So if I have x is equal to -7 cosine of 2 times pi, which would be the endpoint, it's actually evaluating 2 pi. So what it's saying is that the endpoint is a full 2 pi around, and it would just end at where we started. Same thing for y, because the period here is just pi. So we're going to say that for this situation, it begins at -7, 0, and does a full revolution, and then it's going to be counterclockwise. And so that is it for item 27. All we did here was we translated that equation into x and y, which gives us the equation of a circle. And then we found the starting point by plugging in t is equal to 0, which was the starting point of the parameter, into the equations. And we saw that when you plug in 0, we got the point -7, 0. So that's our starting point. And then we saw that the angle t is positive, so we are going to go counterclockwise. However, the period now is just pi, because when I plug in pi for the upper boundary, it's going to evaluate 2 pi, so it acts as though it's doing a full revolution. And that is it for problem 27.